Hello everyone. Today let's solve the Leetcode problem number 48. Rotate image. So what the question says, you are given n into n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. So we have to remember this one. Strictly remember, we have to rotate the image by 90 degrees, that too clockwise, right? So you have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate the another 2D matrix and do the rotation. So they have strictly said we shouldn't allocate another 2D matrix. Instead, we have to modify the same this one in the same matrix, right? So we have to rotate the image in place, which means you have to modify the input 2D matrix directly. So also they have strictly said do not allocate the another 2D matrix and do the rotation. These two things we have to keep in the head. One is rotate the image by 90 degrees, and also we should not allocate another 2D matrix and do the rotation, and we have to modify the input 2D matrix directly. So these two things we have to keep in head. So let's come to example 1. They have showed 1, 2, 3, 4, 5, 6 and 7, 8, 9. So what happens here? This one 7, 4, 1. While we this one when we rotate the image by 90 degrees, this one will come, right? 7, 4, 1. First column, this one will come here. 7, 4, 1. 8, 5, 2. Second column, this one. 8, 5, 2 will come to the second row. And 9, 6, 3. Nothing but this one. Last column. Last column from this one. And the bottom one, 9, 6, 3 will come here at the last row. 9, 6, 3. So the output has to be 7, 4, 1, 8, 5, 2 and 9, 6, 3. Same thing goes for the example 2 as well. So let's try to write the code and understand with example 1. Let's try to implement the example 1 accordingly with the code. So first what I'll do, let's iterate over the each row of the matrix. What we are doing, we are iterating over the each row of the matrix. For that, I'll just make use of for loop, right? Let equals 0, length of the matrix. This is fine. Next, we will iterate over the each element in the current row, starting from the last row, moving upwards. How can we write that? I'll make use of another for loop. We will iterate over each element in the current row, starting from the last row, moving upwards. We'll start from here, starting from the last row, moving upwards, right? So that's what we are doing here. So let j equals, and just assign this one to from the last one, right? So we have to give length of the matrix -1. So yeah, just give me a second. This will be length of the matrix -1. We are iterating reverse basically in simple terms. So this will be j greater than or equal to 0, j minus minus. Simple. We are iterating from here, starting from here. So nothing but we are doing the reverse iteration, right? So next what we will do, we will remove the first element from the jth row. We will remove the first element from the jth row and append it to the ith row. Nothing but we are effectively rotating the matrix. Again I'm telling, we are removing the first element from the jth row and appending it to the ith row in simple terms. So I'll just make use of matrix of I, push of matrix of j. But here and we have to append, right? For appending, I'll just make use of the shift operator. So this is fine. What happened here? So yeah, so this is it. Let me format the code. Let me hit the submit. Let's wait for some time. So yeah, this works absolutely correct. The code works correct, right? So let's consider example 1 and try to implement the same with this code accordingly, right? So just give me a second. So let's consider this example, right? First example I have given. So in the input matrix, they have given 1, 2, 3, 4, 5, 6, 7, 8, 9. The output that we have to get is this one, 7, 4, 1, 8, 5, 2, 9, 6, 3 after rotating the after rotating the image to 90 degree, we have to get this output, right? So initially, so the initial matrix will be same thing, 1, 2, 3, 4, 5, 6, 7, 8, 9 according to the code. Let's go step by step. Initially, the outer loop will be I equals 0 and the inner loop will be j equals 2, right? What we will do, we will remove the 7 according to this one, according to this step, matrix of I, this one. What we will do, we will remove 7 from the last row and append it to the first row. Now, the matrix will look like this, right? So, what we have done here, we have removed 7, 8, 9 it was, we have removed the 7 from the last row and we have appended it to the, we are appending it to the 7, nothing but 7. We are appending 7 to the first row. Now, the first row will be 1, 2, 3, 7. The matrix looks like this. You can see, clearly see, right? Sorry. So, yeah. Next, what we'll do, inner loop j will be 1. Means, we will remove the 4, nothing but we will remove the 4, this one, initial matrix, this one, right? So, we will remove 4 from the second row and append it to the first row. First, we removed the 7 and we append it to the first row. Now, we are removing the inner loop j will be 1. We are removing the 4 from the second row and we are appending 4 to the first row, right? So, after appending 4 to the first row, the matrix will looks like this, right? So, what we have done, we have removed the 4 from the second row and we are appending 4 to the first row. Now, the matrix will look like this, 1, 2, 3, 7, 4, 5, 4 and 8, 9. I hope this is clear. Next step is inner loop j will be 0, right? So, what we will do, we will remove 1 this time, 7, this got completed 7, 4 also got completed. Next, we will come to 1. We will remove 1 from the first row and we will append it to the first row itself, right? So, we will be appending the, we will append 1 to the first row itself. So, after removing 1 from the first row and appending it to the first row itself, now the matrix will look like this. So, let me look like this, right? 2, 3, 7, 4, 1, 5, 6, 8 and 9. So, next, now the matrix will look like this. Next, we will go to the outer loop. Outer loop, I was 0 at the first step, when we, if you remember this step correctly, right? Now, the I will be 1. Now, the I will be 1 and inner loop j will be 2. So, j will be 2. We are removing 8 now. We will come to this one. J will be 2. So, we are removing 8 from the last row and we will append it to the second row. We are removing 8, this one, where the cursor is 8 and we will append it to the second row. Nothing but this one, 4, 5, 6, 8 it has to become, right? So now the matrix will look like this. So, what we have done here, we are removing the 8 from the last row and we are appending 8 to the second row. Now, it will be 5, 6, 8. Next, j will be 1, right? J was 2, now j will be 1 and we will remove this time 5, right? We are removing 5 from the second row and we will append it to the second row itself, right? This one where the cursor is, we are removing the 5 from the second row and we are appending 5 to the second row itself. So now the matrix will look like this, 6, 8, 5. If you observe correctly here, it will be 6, 8, 5, right? So now the inner loop j will be 0. After j was 1 previously, now the inner loop j will be 0. We are reverse iterating. If you here you can clearly see, right? Now the j will be 0 and from the first row, what we will do now, when j is 0, this one, we will come here to this one, right? So we will remove 2 from the first row and we will append it to the second row, right? We will remove the 2 from the first row and we will append it to the second row. Nothing but the matrix will look like this now. What we have done, we have removed the 2 from the first row and we have append it to the second row. Now the matrix is 8, 5, 2. You can clearly see here, right? So this is fine. So next will come j is 0, right? Now we will come to the outer loop. Nothing but outer loop was I equals 1 previously. Now I will be 2. So nothing but we will come here, this one to this one, right? I will be 3 and what we will do, I will be 2. The inner loop initially j will be 2 as well. We will remove the 9 from the last row and append it to the third row. We will come here and we will remove the 9 from the last row and we will append it to the third row itself. This time we are appending this one to the third row itself, right? So after removing 9 from the last row and appending it to the third row, the matrix will look like this. So we can clearly see what we have done here. We have removed 9 from the last row and we are appending it to the third row. So this will be 3, 7, 4, 1, 8, 5, 2 and 9, 6. This look like this, right? So next inner loop j will be 1, right? Inner loop j will be 1. So what we will do, so here we will come when j is 1, here we will come, we will remove the 3 from the last row and we will append it to the, 3 to the this one, third row. Means we will come here, we will remove 3 and we will append 3 to the third row. So after removing 3 from the first row and appending it to the third row, the matrix will look like this. Basically 7, 4, 1, 8, 5, 2 and 9, 6, 3, right? So the final rotated matrix that we got is, this one, 7, 4, 1, 8, 5, 2 and 9, 6, 3. So what we have done here is, the matrix rotation involves shifting of elements, right? We have made use of the shifting in the code, if you can remember, row by row from the last row to the first, essentially transposing the matrix and then reversing the rows. This transforms the original matrix into a 90-degree rotated version. So the final matrix that we got here is this one, and here they have showed the output matrix as well, right? So this looks like this: 7, 4, 1, 8, 5, 2, 9, 6, 3. The output that we got is 7, 4, 1, 8, 5, 2 and 9, 6, 3 according to the code. So this one. So the solution that we got is equal to the output they have given here. So the code works absolutely correct. Let me delete this one. Yeah. So let me delete this one as well. The matrix. This was just for the reference. Sorry. Just give me a second. Delete this one. So what will be the time complexity and the space complexity? The time complexity would be, so the outer loop here, this one, the outer loop is nothing but this one. The outer loop runs n times, right, for each row, and the inner loop runs n times as well for the each column. So overall time complexity would be big O of n to the power of 2, right? And what will be the space complexity? We are making use of the constant extra space, which is constant, right? So we are making use of the extra space. We are making use of the constant extra space. Nothing but overall space complexity would be big O of 1. So let me comment this one. Let me format the code again and let me hit the submit. So yeah, this works. The code works absolutely correct. So this is it. Thanks for watching, guys.